Hello everyone. So in this video, we'll understand about GraphQL. But before even going to what GraphQL is, let's first understand how do software systems talk to each other. Let's talk a bit about it. So just how people are social, they like to chat with each other all the time. Computers are social too. These software systems talk to each other via something called as APIs, which is Application Programming Interface. Now, think of an API like a restaurant waiter. This is a wonderful analogy. We'll be using this analogy to understand GraphQL, REST, and all of the lecture here. So, let's say that API is like a restaurant waiter. Now, if you see in this diagram, the customer says, okay, bring me a particular dish. He conveys that message to the waiter, and then the waiter chats with chef, and based on that communication, after some time, waiter brings that food or dish back to the customer. That's how things happen. But all of the communication happens via this waiter. Now, API is very similar to that. We have two different software systems and they chat with each other via this API, which is like a waiter. Now, there are multiple ways in which this communication via API happens. These are basically API types, and one such type is the REST, which is also known as the representational state transfer. I'll explain you this concept using a very similar example here. So, as you can see, the customer has the menu with him. He says, I want a burger with fries from menu, please. That gets conveyed to the waiter, and then the waiter talks to the chef, says, hey, chef, customer 1 wants burger and fries from the menu. So, chef works on it, and then after some time, the waiter gives that burger and fries back to the customer. That is how the communication happens here. Now, if we dive deeper into it, what just happened here? So, customer wanted standard things that such as burger and fries from the menu and not some custom item. And that is what is different here. So, as you can see, this is the whole thing written here, but it says that the rest is a very standard way of communicating. You can't ask for custom things. We'll take a look on what custom things mean in when we understand GraphQL. But the gist is that you can order from the standard menu. Now there are 4 different methods that are commonly used in REST, which is HTTP GET, which is when client wants to get data from the server. The second one is HTTP POST, which is client wants to create data or write data into the server computer. Then there's HTTP patch for updating data and for deletion, HTTP delete. Very straightforward. Now let's move on to GraphQL. Now what happens in the GraphQL case? The customer definitely has a menu with him. Now he says, I want a burger with extra pickles, extra cheese, and a gluten-free bun. Very fancy, right? But the waiter just accepts it and the order goes on to the chef. He says, hey chef, customer 1 wants a customized burger with multiple different things, as I said. And then once the order is done on the chef's end, the waiter presents that order back to the customer and the customer is happy. So that's how the flow happens here. Now, if you notice, the customer here asked for a custom order, which wasn't possible in the REST case. So unlike REST, where you get the standard menu items, GraphQL lets you request customized menu items. And if, let's say, this order was ordered using REST, how would that look like? You need to order each of these items separately. The gluten-free bun, extra pickles, extra cheese, and once all of that was delivered, you would be the one to assemble all of that into a burger. Not that fancy, right? So with GraphQL, you describe your custom burger in one order and the waiter just understands the detailed request and brings back your order. And that is why Facebook created this GraphQL, because it's very efficient and it's flexible on the data that we want. And thirdly, think of mobile use cases where you want lesser bandwidth. And that is where GraphQL shines, and that is why it's used a lot. Now let's talk in more technical terms. What was the problem with REST that we had to move to GraphQL? Let's formally write that down. So the first one is overfetching and underfetching. let's clearly understand this. So REST returns fixed data structure, as we saw, like fixed menu items. You often get too much or too little data. So let's try to take a small example to understand this overfetching and underfetching problem. So let's say this is the user and he says, give me user info. It goes to, let's say, user service, and whole lot of data is given back to the user saying that, okay, name is XYZ, address, occupation, and whatnot. But the user only wanted the username. So this is basically overfetching problem. We wanted only username, but we got a lot of data. Not needed, right? Now let's talk about overfetching. Let's say this user wants to get all of the posts of his friends on social media. For that, in REST format, we'll have to go to the user in user service to get the user info, then find all of the friends for that user using the friend service, and then get all of the posts from these users from the post service. Well, a lot of chit chat between the services and the client. Don't you think it's inefficient? And that is why GraphQL came into the picture. Now, if we had to do that with GraphQL, we would just say that give me all the posts from my friends, and then GraphQL would just simply return all of the posts. Very, very efficient in comparison to REST. Now, if you see, GraphQL solved the problem of overfetching and underfetching. GraphQL is fetching exactly the thing that we want, not more, not less. So we don't have to make multiple round trips to different services and then combine them and then filter some of the items there. So that is why it's very efficient. If we are chatting about multiple round trips, don't you think when we are doing multiple round trips, it will increase the latency of the system? So that is why GraphQL is recommended here. And that is what we have written here exactly. So the overfetching and underfetching problem is there with REST, and we have to make multiple round trips. This increases latency and clutters the client logic too. And I would say there are more limitations to REST, but these should give you a fair bit of idea why we moved on to GraphQL. So now we know that GraphQL solves the problem of overfetching, underfetching, and multiple round trips that we see in REST. And that is why it's used a lot nowadays. But how does it actually solve this problem? Let's try to go deeper and understand this. And before trying to even understand this diagram right here, let's just take a look at few of the basic keywords here. So the first one is a schema. Now, schema might be a misleading term. This isn't the same as a database schema. It's more like a contract between the front end and the back end, stating that, okay, the front end and the back end will be communicating in such and such fashion. This is the kind of data I'll be giving to backend, and backend says, this is the kind of data I'll be sending you back. So it's like a contract. The second term that we need to understand is a query. Query is like a read operation here. You can ask the server for a specific data like a username, post title. Query is like a read operation. Now, mutation is like a write operation. It's just the naming is different here. So, query is like a read operation and mutation is like a write operation. Now, the fourth one is a resolver. Now, the whole major crux of GraphQL lies in this resolver. So when we send a query or mutation to this GraphQL engine, the engine doesn't fetch data on its own. It has its special functions written here. So let's say the functions could be get me all of the posts for this user's friend, or it could be add a post for this user. So there are specific functions that are written in the GraphQL engine. These are not actually present there. We as a developer have to write these in the GraphQL engine. So these resolvers, as I said, are responsible for fetching and modifying the actual data. These will be communicating with the user service or post service or different services and databases and make changes, or maybe even call different APIs to actually find that data for you. So these are the basic words, quite overwhelming right now. So as always, let's take an example to understand this. So in this example, let's say the query looks something like this. As you can see here, the front end is trying to query for a particular user with ID 1, and he wants to have the name and all of the posts from that user. And then this query goes on to the GraphQL engine, and after all of the calculation and manipulation, the result is returned back to the front end. Now, how does that whole step happen? It happens in 4 different steps. So now let's take a look at all those 4 steps. So these 4 steps look something like this. The first one is parsing. So whenever a query comes, it converts it into a machine readable format. In this case, an AST. We'll take a look at what AST is, but let's say it's a machine readable format. Then once the parsing is done, it moves on to the validation. In the validation step, it basically checks the query against the schema that we saw. Does the whole query that we have sent conform to that schema or not? So that is the validation step. Then it moves on to the resolver execution, and as the name suggests, it executes the resolver with arguments. It basically runs those resolvers to get the data for you. And finally, there is response formatting to just eliminate all of those not required fields or to format the whole data in the format that you wanted. So let's understand all of these 4 steps using the example query that we saw earlier. So as I said, the first step is parsing. So the GraphQL parses the query into a machine readable format called as abstract syntax tree, and you can understand it like a tree where the query has one branch for the user has 2 branches for name and post, and then the post has 1 branch for its title. We don't need to go deeper into this abstract syntax tree, but just understand it like a machine readable format that machine understands, and it's like a tree. Now, once the parsing is done, then we move on to the validation part. Now, as the name suggests, it just validates that the query that we have sent is valid or not. What does valid mean here? So let's take this example. In here, we see that the query is for user with ID 1. So the first check that we need to do is there a field for user or not? We see the schema. Okay, there is a field for user. That's good. Then the next question comes up, does the user accept an ID argument or not? Then the third step could be, does the user have field like name and post or not? As you can see, the user does have name and post in it. And similarly, we can see, does post have title in it or not? In the second field, as you can see there is a title inside the type post. So all looks good here. Now, once we are done with the validation, we move on to the step number 3, which is resolver execution. And as we saw earlier, in the resolver execution, the GraphQL engine has different kinds of resolvers. There are like query resolvers, there are mutation resolvers. In this example, we are doing a query. So it will look for all of the query resolvers and then look for all of the different kinds of methods there. All of these resolvers are, if I say in simple terms, these basically talk to different services and then return the result. So if we look at our query here, we have the query user ID 1. So the first step would be to call query.user with ID 1. Now, with that, it will return ID 1 and the name Alice. In the second step, it will go inside the user. That is, it will look at name and posts in here. So then it will go to find out with another resolver saying what is user.name. Then it will return Alice. And thirdly, it will go to user.posts and that will return all of the posts, title and content. Here we have only indicated title, but there should be title and content. In the fourth step, when we say that we want post.title, then we go to the post.title resolver and then that would return all of the titles for all of those posts. So it happens in 4 different steps and each of those 4 steps go to different kinds of resolvers. And finally, once we have collected all of that data, then we move on to the 4th step, which is response formatting. So in this step, the GraphQL shapes all of the response that we got in the previous step to exactly match what the client requested or the front end requested. We do not pass on any extra data. We just filter out all of the not needed data. So let's say the resolver returns something like this. The name and the posts, and in each of those posts we had title and content. But the client only wanted the post title, not the content. So this is where the response formatting happens, and the GraphQL then returns the data in this format. So in summary, GraphQL did these 4 steps. The first one was parsing the query, basically converting the query into machine readable format. The second step was validation or validating according to the query. The third one was resolver execution, basically calling all the resolvers on different steps to find out what the data was. And the fourth one was response formatting, where we filter out not needed data and return exactly the requested fields. And that basically sums up how GraphQL works under the hood. Well, that's the whole summary of how GraphQL works under the hood. And I hope you understood quite a bit from this video. I hope to see you in the next one. Just stay tuned.